right, so the first thing I'm going to do is I'm going to record I'm going to make a little clock here. I hope that works. That might be big enough. And then I'm going to put down all the numbers needed for this yearly clock. And then I'm going to explain every little thing. So, let's get started. So I'm going to put 4 and 5 and 6 here, and 6 and 5 and 4 and 3 and 2 and 1 and 1 and 2 and 3. So altogether I should have about 12 numbers, regardless of if there's not, even if it's not 1 through 12, so we'll count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, 12 of them total. 12 total, okay? Next step we're going to do is I'm going to label them in segments, so in seasons I should say. So I'm going to put spring, summer, and autumn, or they say fall, and winter. So each season gets 3 pieces of the pie, or 3 slices of the pie each season. So spring gets 3 slices, summer gets 3 slices, autumn gets 3 slices, and winter gets 3 slices. Everybody gets a fair share in each of their quarters. Okay? So these numbers are going to represent like months. So months 1, 2, 3, 4, 5, like I kind of did earlier, all the way to 12. Okay. So the $1 million question is, how do I know, or how do you know where to get started in the whole year? Where does it begin? Where does it end? So I'm going to be using the equilux in order to trace this year. And so it's going to be right here. I'm going to put it right smack right in there in the middle between the 4 and the 3. So this is where my end of the year piece is going to be to divide winter and spring. But you also have to divide spring to winter. And if you follow me on Facebook, you're probably familiar with what I've been saying, the Mexilux, which is going to be between spring and winter. I'm sorry, spring and summer. And then for the autumn, it's going to be the opposite of autumn is spring. So it's going to be another equilux somewhere between autumn and summer. And then for the winter, it's going to be the opposite of summer. Okay. All right. So these are the similar to 2:00, 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. And I'm holding this on my cell phone. I'm sorry. All right, so I'm going to zoom out so you can all see this. So you see it? Okay. Now, the next step is, where do you find these signs that, since I'm not doing an equinox and a solstice, it's easy to find the equinox and solstice, but the $1 million question is, how do you find the equilux? So here's the first thing we're going to do. Numbers work well together when you add them up. So this is what we're going to do. We're going to do the final. First, before we even look at latitudes, I'm going to add 4, 5, 6, 6, 5, 4, 3, 2, 1, and 1, 2, 3. What I'm going to do is I'm going to add these numbers up. These numbers are nothing but addition. I'm adding everything up. The answer is 42. I'm just saving time here. Okay? Answer is going to be 42. All I did was just add these numbers up to get to the answer 42. And the largest number you see is 6, right? I'm going to add the 6 up. Why am I adding up to 6? I'm going to tell you why I'm adding up to 6. Because 42 degrees, because since I'm going to identify the latitude in order to find the equilux, in order to find the equilux, if I try 42 degrees, I'm not seeing 16 hours day and 8 hours night. But when I add the 6 to the equation here to get 48, I actually do see what I need to see when I'm finding latitude when we get up here. But we're just going to take it nice and slow. All right, so 48 is what I get. So I know that when I use the solar calculator, I know that if I want to see 16 hours day and 8 hours night, I just simply check the 48 degree latitude off any solar calculator, and it's going to show up either in June or negative 48 for winter. And just fast forward, shrink it, whatever, and I would see 16 hours day and 8 hours night, no matter what. But what I'm not worried about that right now. We got to find is this bad boy right here. So I know that if there's an equilux and it marks the end of the year, then I know that we're still in the third portal, or at the number 3, not the number 4, which represents a new year. So I'm going to take the 48 and I'm going to divide that bad boy by 3, which represents the third portal right up here. I'm taking that 48 and I divide it by 3 so I can get the right latitude that I need. Now that's calculated up and work it all together. And it should be 16, but here, let's just really make sure before, let's just really make sure, but I think it's 16. I'm terrible at math, believe it or not. I am terrible at math. Oh, okay, I was right, 16. Okay. Alrighty. So I know 16 degrees. If I want to get around that equilux, then I know I use 16 degrees latitude. Now, what we're going to do next is what we do at the top. Well, since I divided 48 by 3 at the top, I'm going to do the same thing at the bottom, 48 divided by 4. So let's do the same thing. It's kind of like what you do to one side, you do to the other side. That should be 12. I'm going to just double check. It's always good to double check because, you know, it's still so much easier when you just got back up here. So you got 12. So, okay, so these are my 2 numbers that I'm going to need in order to track these equiluxes. And so the next thing I'm going to do is I will be right back because I got to get my tablet. I'll just be right back. Don't go nowhere. I'm going to get my tablet so we can measure out these equiluxes, okay? Hold on. I should have got my tablet before I started. Where did I put my tablet at? Hang on, I gotta find my tablet. Everything is recording. I can't find my tablet. So I'm probably gonna cut it off. Okay. I can't find my tablet right now, so I'm just gonna have to get this. I'm just gonna have to use this. Alright. I'm sorry, y'all. Okay, let's just use this. This doesn't matter. A solar calculator is a solar calculator. Alrighty. So the first thing I'm gonna do is I'm going to get out of here, and I'm gonna go to let me see. This is not the solar calculator I like to use, but I'm gonna use it. I gotta start from scratch. Okay, so here we are, latitudes, right? So the first thing I'm going to do is use the 16. And since spring is opposite of autumn, spring is up, autumn is down. How I know it's easy, you could easily remember it by the leaves grow up, and then when it's autumn, they come down. So spring is positive, autumn is negative. So okay, let's see. There we go. And let's see, I want to get rid of that 0. I guess I gotta just do it this way then. Just do it that way. There we go. 16 degrees. I save it. And where did it show up at? It must be down here. Yeah, there we go. Okay, 16 degrees. And I know that spring is somewhere around March, so I'm going to change the date to March. So March, it doesn't even matter. I can do March 9th. That's fine. I just needed to be March. Then I hit display here. Okay, so we had 16 degrees. 16 degrees latitude. And that's in March, because I know springtime is in March. So what I'm going to do is I'm going to go forward until this shows up at 12 hours exactly. So I'm going to hit this. Keep going. Keep going. Keep going. There we go. So it showed up 16 degrees latitude at 12 hours exactly of total daylight. So I know that would be what I'm looking for. Let me go forward again, make sure that it is not the next day as well. Cool. March 14th. Now, that's 16 degrees latitude. So here I just write this down. And put down for 16. I'm just going to, that's at March 13th. All right, now we got to do the other equilux at 12 degrees below the equator. So we do the same thing I just did on this solar calculator. I'm going to go to for the location. And since autumn is negative, we just do negative. I just can start these decimals all over. And 12.00000. Done. And that's positive. I need negative. Okay, here we go. There we go. south. There we go. I'm gonna hit save. I'm gonna go to hit the latest location. Okay, there we go. There's that -12 right there. Now it's on the latitude. So I know that autumn time is around September. So I'm just going to go to September. And September, any date doesn't matter. 4th, 5th, 6th doesn't matter. And then I'm going to click display here. So like I did in the spring, I'm going to do the same thing I did in autumn. I'm going to keep going forward until I see an equal day and equal night. So we're going to do it. So it says September 4th, 11 hours and 55 minutes. So we know I'm almost there. That's the 5th, 6th, 7th, 8th, 9th, 10th, 11, 12. I'm going to go forward one more time. I just want to make sure it's over with. 13. There we go. I'm going to go forward one more time. Okay, so September 12th through 13th is this equinox right here. So here I'll write it down. So that bad boy lasts for 48 hours. So I'm write down that date. There we go. Now the next thing we're going to do is I'm going to go to timeanddate.com and I'm going to see if these two equinoxes are 182 days apart. So I'm going to have to go use this. Bear with me, y'all, because I get my tablet. Timeanddate.com. And let's see. I guess this is what I want. I think that's what I want. Yeah, this is it. So what we're gonna do is when that loads, I'm going to count these days, see how many days apart March 13th and September 12th is. Calculators, date to date. Alrighty, so I said March 13th, 2018. March 13th, 2018 to September 12th, 2018. Oh, come on. This is why I wanted a tablet, because it's bigger. This thing is, no, there we go. Okay. All right. In 2018, so it's the same. And then I hit done. And let's see what we get. Are y'all 182 days apart? Yeah. Good. So it says 183 days apart, and I'm fine with that. You know why? I'm gonna tell you why. Because I'm gonna go back to time, and I'm gonna go back to my solar calculator, and I'm gonna hit 19.5 degrees, and I bet it's gonna say what I normally say. I gotta show you how they get 19.5. I'm going to go back. Cause see, this latitude is a lot stronger than the than 16 degrees. I really like this latitude a lot better than 16. 16 is good, but 19.5 is just so much stronger. All right, March. Display you. Okay, so I'm going to go forward. So that's March 14th. You just see the difference between March 4th. The difference between using latitude 16 degrees to latitude 19.5 degrees. So this latitude was March 14th, and it's 12 hours a day. So I go forward, and then that's what I've been using anyway. I'll get to how I got 19.5 degrees because you can't actually get it through here, do the proper calculations too. So now I'm going back to timeanddate.com, and then I'm going to put back in the new dates, March 14th, and then calculate, and then I should get 182, and I got 182. 182 is a great number. Ugh. So, and why 182? Easy. Because 182 plus 182 equals 364. So I know that's half the year. However, this down here what shows that this equinox didn't end until after March 13th or March 14th, then the equinox was over with. So it's telling me, you count those as the same station and not the different station. It keeps everything balanced. So that's the calculation of the two equinoxes, is to get these numbers. You add up the total portals, you get 42. You add up the 6, and so we're gonna focus on this 48. Why 42 plus 6? Show you. So let's see. I go back, and this time I'm gonna put in latitude 42. Because you literally get 42 when you add up all the gates. And I'm going to show it's no 16 hours day and 8 hours night. Because I need the day to be double the night. And 42 degrees just can't do it. So I know that I know that summer is around June. So, like I did the other months, I just go to June. I'll go to June 5th, June 3rd. That's fine. All right, so we see here we are at 15 hours and 11 minutes. So I'll keep going forward until I get to 16, but it's not going to happen because it's not a high enough latitude. I need to go higher. That's why I like 48 degrees, because 48 degrees is a lot. It's perfect. By adding in that 6 is perfect. So I just had to do it this way. 48. 48 degrees latitude. Hit that save button. Then I'm going to go to it. And I'm going to just keep going till I get exactly 16 hours a day. And then make sure it's lined up with that equinox. So here we go. Here we are right here. Okay. So here we are right here. June 13th, 2018, 16 hours a day. So that means if it's 16 hours of daylight, then it's 8 hours exactly of night. And you can't get that off no other calculator. I mean, you can't get that off no other latitude. It's only 48. If I go to 49, then it's too many hours. And it doesn't line up exactly 91 days from the equinox. So the next thing we're going to do is I'm going to count. I'm going to go back to timeanddate.com and I'm going to go back to March 13th, or actually March 14th when I changed it to 19.5. And I'm going to see how many days it is from March 14th to June 13th. And let's see how many days we have. So back here. And so I changed this to June. Let's see. They are 91 days apart. Just like I want them to be. 91 days apart. So I know that this equilux to this mexilux is 91 days apart. So now, let's see how many days apart from this 16 hours day, 8 hours night to this equilux. So that was June. Let me write that down. I gotta write down. I'm gonna write down June because it happened on June 13th. June 13th. So June 13th. Shit. To September. Let's say September 12th through 13th. I'll put down September 12th because it shows up there first. I worry about the 13th later. Hit that calculation button and let's see. And they are 91 days apart as well. So I'm going to put down the 91 days apart. So I know that spring is 91 days. Summer is 91 days. Now let's see if autumn is going to be like that. So here's the thing about autumn. Autumn equilux is 40 hours long. So I'm going to count from this to the winter mexilux starting from September 13th. That I'm going to get the whole mexilux. So first thing is we're going to get since summer and winter are opposite seasons, winter is going to be negative 48. So we're going to do the same formula. I'm going to do negative 48. And I better put that decimal there because if I don't put that decimal, it's going to think it's going to be 48 million. But yeah, that's what I want. Negative 48. So I know that winter is around December. So I'm going to go to December. It don't matter. I go to December 4th and then just do like I did the other seasons. All right. So here we have 15 hours and 47 minutes a day. So let's just go forward until I get to exactly 16 hours. That's December 8th, 9th, 10th, 11th, 12th. I'm going to go up 13. This should do it. I'm sticking with December 13th, not December 12th. I guess if I did December 12th, then I have to count from September 12th to December 12th. But I'm counting here, and I know that you have to do 91 days. So we're going to go back. I'm going to write down December 12th. I'm sorry, December 13th. December 13th. And we go back to timeanddate.com so we can calculate the new date. So it's going to be from September 13th, 2018 to December 13th. Calculation, and we got what? We got 91 days. So that's also 91 days. Let me just, I don't know if you saw the date. So I put down the end piece of the equilux on September 13th to the maxilux, or 16 hours day, or actually night, December 13th. So I got 91 days. So I know that this bad boy is also 91 days. So autumn is 91 days apart. So we just make the line here to finish off the rest of the year. Now we got one more to go. We got to do winter to the equilux, right? In order to do that, we go back to the solar calculator. And like I said, I'll show you how I got the 19-degree mark, because the 19.5 degree mark, I'm going to display that too. So I'm going to go to the month of March, and got to go to 2019. And I got to also put down my 19.5 degree mark. That's not it. Here we got the 19.5 degree mark on March 13, 2019. I'm going to go forward one more. So that equilux comes back on March 14th. I'm going to write it down. Equilux on March 14th. And timeanddate.com from December 13th, 2018. December 13th, 2018 to March 14th. March 14th. And this time it's got to be 2019. And then I hit the calculate, and 91 days. So also 91 days apart. So Jubilees was 91 days apart.